My dear students, today we are going to see about the geometrical description of conic sections. So for that one we need a double napped right circular cone. I think it is the best example. Okay, I think all you know what is that instrument. So it is a double napped cone. Okay, so it is both the ends are meeting at a vertex. Okay. So we are getting the different conic section between the intersection of this double napped cone and a plane. Okay. So think of the double napped cone. So both the bases are a circle. So it is the vertex and it is called as the axis. Okay. So and if we rotate this line with respect to that axis, we are getting a double napped right circular cone. Okay. So the angle between the axis and this is called as a generator. It is denoted as alpha. Now the angle between the cone and the plane is taken as beta. Okay. Suppose if you are intersecting this plane just vertically opposite to that cone axis, if we cut vertically opposite to the axis, we are getting a circle. That means the beta is equal to 90 degree, we are getting a circle. Second one, if beta is less than negative but greater than alpha, look at that, this beta is less than 90 but greater than alpha, we are getting a ellipse. Okay, and suppose if the value is I think it is parallel to the generator, if the angle is parallel to us like the generator, we are getting a parabola. And the fourth one, if we just along the axis if we cut, we are getting a hyperbola. This is the geometrical description of conic sections. Second one, the generating forms of conics. Okay, degenerating forms of conics. So either it may be a point or a point circle or a line or pair of lines or intersecting lines. Suppose this plane intersect at the vertex. So we are getting a point circle or a point. Okay, or we are along the generator, we are getting pair of parallel lines. Suppose if we intersect the plane along the axis, we are getting intersecting lines. Okay, so the parallel lines, I think it is the generator of some other conic sections. Okay, from the degenerating form, they are called as degenerating. So it generates something. Okay, so again now we have 8 things. Okay, so parabola, ellipse, hyperbola, point, pair of parallel lines, intersecting lines, and another one case is there we are discussing later. Okay, so if any general equation of a conic is given, look at the equation, capital ax square bxy plus cy square plus dx plus ey plus f equal to 0. It is a general second order equation. Okay, it denotes a conic. So how can we identify what is the type of the conic from the general equation? So we can see it elaborately. So first condition, if both a and c, coefficient of x square and coefficient of y square equal, and the meantime coefficient of xy b equal to 0, it represents a circle. Look at the other condition, it is not needed, it is only necessary and sufficient necessary condition. If a equal to c and b equal to 0, the general equation of conic is a circle. The second one, b equal to 0, obviously either a or c, only a equal to 0 or c equal to 0, then it becomes a parabola. Okay, third one, both a and c are not equal. A and c are not equal but same sign. Same sign means both a and c positive or negative, then it represents an ellipse. Okay, fourth one, similarly the same, a not equal to c and the opposite sign, positive negative or negative positive means it represents a hyperbola. Are you clear? Fifth one, if A equal to C and all the other values are B, D, E, F becomes 0, it represents a point or a point circle, x square plus y square equal to 0. Sixth one, A, C and the constant term F, all the three are equal and the remaining three B, D, E becomes 0. It denotes an empty set. It may be represented by the equation x square plus y square plus 1 equal to 0. Here we have no real solution. Okay. And if A not equal to C or C not equal to 0, either A not equal to 0 or C not equal to 0, all other values are 0. Okay. B, D, F, all other values are 0. It represents coordinate axis. Coordinate axis means either x equal to 0 or y equal to 0. Last one, if A equal to minus C and the other values are 0, it represents pair of lines x square minus y square equal to 0. Once again, look at all the 8 cases. With the use of the 8 cases, we are identifying what is the conic denotes. What is the type of the conic. Okay. So look at the first one, A and C are equal and B0 means circle. B0 either A or C, only one 0 means parabola. A and C are not equal and same signs mean ellipse. A and C are not equal, opposite sign means hyperbola. A equal to C, remaining values are 0 means it is a point circle. A, C, F are equal, other values 0 means it denotes an empty set. Okay. A not equal to 0 or C not equal to 0, other values are 0 means it represents coordinate axis. A equal to minus C and all other values are 0 means it represents the pair of lines. So if you know this concept, you can easily answer the exercise 5.3. Okay students, now we can see the problems in the exercise 5.3. There are 6 problems. Okay, so look at the first question. The question is identify the type of the conic. Okay, so question is 2x square minus y square equal to 7. Look at here. Here A equal to 2, C equal to minus 1. So A not equal to C. In the meantime, A and C are opposite sign. Therefore, it represents a hyperbola. So first one is a hyperbola. A not equal to C. And A and C are opposite sign, therefore it represents a hyperbola. Second question, A, C both are 3 and B value 0, therefore it represents a circle. It represents a circle. Okay. Third one, A value 3, C value 2, A not equal to C. In the meantime, both are same sign. Here opposite sign, here same sign, therefore it represents an ellipse. Okay. Fourth one, again look at here, it like a second question. A and C are equal to 1 and B equal to 0, that's why it represents a circle. Okay. Fifth one, A equal to 11, C value minus 25, both are not equal and opposite sign, therefore again a hyperbola. Okay. So last one, look at here, there is no x square term, that means A 0 but C not equal to 0. A 0 but C not equal to 0, therefore it is a parabola. So very easy exercise, that's all.